Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 99th of physics, and in today's lecture we are going to discuss pitch, loudness and quality of sound. These are the three characteristics of sound through which we can differentiate between different sounds. In this regard, we are first discuss the pitch. Uh, Dear learners, every day we are surrounded and bombarded by a great variety of sounds. Sounds such as those produced by radio, television, and musical instruments are useful, while sounds such as those produced by construction work, jet planes, and MRT and the traffic on a busy road are unwanted. We may describe sound in terms of its pitch, loudness, and quality. So let us discuss pitch. Pitch is a perpetual property of sounds that allows their ordering on a frequency related scale. Or more commonly, pitch is the quality that makes it possible to judge sound as higher and lower in the sense associated with the musical melodies. When we describe a musical note or sound as high or low, we are commenting on the pitch of the sound. Pitch is relative. What does it mean? It means that the pitch of a sound is judged in relation to other sound. How? For example, a 200 hertz sound has a high pitch in relation to a sound of 100 hertz. However, the 200 hertz sound has a low pitch in relative to a second sound of 400 hertz. Pitch is related to the physical quantity called frequency. Dear learners, remember that pitch depends on the frequency. The higher the frequency, the higher the pitch. When you double the frequency, you raise the pitch by 1 octave. Whatever the value of frequency is. For example, when you change from the 256 Hz C notes to the 512 Hz C note, the pitch is raised by 1 octave. Ladies and gentlemen, remember that octave is the unit of pitch. When you double the frequency or make it half of the fundamental frequency. For example, pitch can be taken as the measure of sound frequency expressed in terms of hertz. Now, what is octave? An octave is the interval between one musical pitch and another with double or half its frequency. How? For example, if one note has a frequency of 440 Hz, the note 1 octave above is at 880 Hz, which is the double of 440 Hz. And the note 1 octave below is at 220 Hz, which is half of the 440 Hz. The ratio of frequencies of two notes an octave apart is therefore 2 ratio 1. We can study the concept of pitch in the school laboratory by means of two tuning forks of different lengths. The two figures show a tuning fork with long prongs and a tuning fork with a short prong, producing sound waves of different frequencies. When set into vibration by hitting the tuning fork with a hard rubber mallet, both tuning forks will send out sound waves of different frequencies into the surrounding air. Now, dear learners, you can see that these are the two picture. One is this one and the second one is this one. The first one is this. These two tuning forks are of different sizes. On the left side, you can see that the tuning fork with long prongs produce lower frequency sound waves of longer wavelengths. You can see that the wavelength of these are what they are of longer frequencies, while tuning fork with the short prongs produces higher frequency sound waves of shorter wavelength. If the wavelength is shorter, the frequency will be higher, and if the frequency is lower, then wavelength will be uh, longer, because they are the reciprocal of each other. So, dear learners, if two prongs are producing frequencies of different hertz, then it means that the waveform will also be different from each other, and that can be observed through the oscilloscope. The waveform of sound can be observed. In order to observe the waveforms of sound waves of different frequencies, the usual method is to allow these sound waves to strike a microphone, which then convert the sound energy fed into a cathode ray oscilloscope into electrical energy is shown in the figure, this one. So when we observe the wave form of both, we will see that the two tuning forks of different lengths, the waveform produced on the screen of oscilloscope with the same time base are as follows, and you can see that in this particular figure. This is the wave form for longer tuning fork of lower frequency F1. On the other side, this is the waveform of shorter tuning fork of higher frequency F2. This is of lower frequency because the number of waves per second is higher as compared to the figure on the right side of that figure. So, in nutshell, pitch is a subjective quantity that is related to the objective quantity of frequency. That is the nutshell. It means that pitch is totally depending on the frequency. Higher the frequency, higher the pitch. Lower the frequency, lower is the pitch. Whenever we are talking in very simple words, if somebody is talking in high tone, we can say that lower your pitch. Or if you are not being able to hear a person clearly, your ear is not responding properly to that sound, you can say that the pitch of your sound is low. Make it high so that I hear it clearly. One more information I can give you, that the pitch of the sound of women is higher than the pitch of the sound of men. It means that the voice of women can be heard long way, while the sound of the men can be heard in shorter area, not in longer way. This is the natural property of the sound. In other words, this is a God gifted property of these things. Uh, the two figure is showing that uh, time period is, you know that time period is 1 over f. So if frequency is lower, then it means that the time period will be high. If the frequency is larger, then the time period will be what? That will be shorter. So that was the first characteristic of sound, which is totally depending on the frequency. And very simply, in nutshell, we can say that if the sound is lower, its pitch is low. If the sound is higher, then its pitch is high. That's it. The next is the loudness. This is another very important characteristic of sound. Loudness of a sound is a subjective quantity. Remember, it is totally depending on the amplitude. Higher the amplitude, higher will be the loudness of sound. Lower is the amplitude of sound waves, that will show you that the loudness of sound is lower. Loudness of a sound is subjective quantity. What does it mean? For a particular volume, some may say it is loud, while other may say it is soft. Loudness related to the objective quantity of amplitude. The larger the amplitude, the louder the sound. These two figures shows two waveforms of the same frequency. Now frequency is the same, but with different amplitude of vibration. So that is called the loudness. The third and very important characteristic of sound is the quality of sound. Dear learner, if the amplitude is the same and the frequency is also the same, then can we differentiate between these two sounds? Yes, we will differentiate between the two sounds if the amplitude and the frequencies are the same by its quality. So, quality of sound is also known as timbre of sound. Is that characteristic which enable us to distinguish one sound from another, having the same pitch and loudness. The sound which is more pleasant is said to be of a rich quality. Although the frequency and the amplitude is the same, but one sound is pleasant to the ear, but other sound is not pleasant to the ear, then we are saying that sound which is very pleasant to the ear is of good quality. That is a good quality. For example, musical sound. So, musical sound is always feeling good to the ears. Now, in the two first pictures, you can see that the amplitude of this and the amplitude of this sound is the same, and if you are seeing it, the waveform is different. There is distortion inside this waveform, but these waveforms are very smooth, and you can see in this one as well there is a distortion, much more distortion inside it. This is the waveform produced by a violin. This is a waveform produced by a recorder, and this is produced by the tuning fork. So whatever sound feel good to your ear is of high quality. Always when you are listening music and one sound will look good to you and the other will feel bad to you, although both the sounds are of the same frequency and same amplitude but of different quality. If the same frequency and same amplitude sound is produced by a violin or produced by a trumpet, then both the sound will be differentiated by its quality. You will understand that this is the sound of violin because it is having one quality, and this is the sound of trumpet that is of another quality. So the same note played on different musical instrument sounds different, although the frequency and amplitude are the same. Why? The sound produced by musical instrument are made up of a fundamental frequency with many harmonics of higher frequency superimposed or added. Different instruments give different numbers of harmonics, which when added to the fundamental frequency produce different waveforms to give the characteristic quality to the sound produced from each instrument. In case of a tuning fork, the waveform produced is a sine curve. For other instruments such as recorder and the violin, the waveform are different even though the notes produced have the same frequency and amplitude. Ladies and gentlemen, so there were three characteristics of sounds. Now a sound can be differentiated by either the pitch or loudness or quality of the sound. With this, we came to the end of this theoretical portion. Tomorrow, we will start the exercise of this unit. So, stay tuned, don't go anywhere. Thank you very much for your time. Allah Hafiz.